All right, so let's do a quick review of scientific notation. And the main part I want to review, okay? If I have this is multiplying scientific notation, by the way. And it's exactly what that implies, okay? Multiplying scientific notation. Some things that you need to know that you already know, okay? If I am multiplying exponents and they have the same base, who remembers what do I do with those exponents?
Add them.
You add the exponents, right? Okay. Does it matter if they're negative?
No.
Mm-mm. Okay, so first thing, if I have a number that, okay, let's just say you're going to be able to use calculators for this because there's going to be some decimals involved, okay? I don't mind if you use calculators, but just the same as last year, what's my rule if you're going to use calculators? Show me what?
Your work.
Show me what you're putting into the calculator, okay? So if you need to borrow one of mine, please do so according to your number.
That's 9.
Yes, sir.
Okay, chop chop, my people. Let's go. Okay, so let's start. Okay, I'm going to give you a problem. Okay? Visualize if you're in the rainforest, okay, in the Amazon. Okay, what's all over the ground? I'm looking at ants.
Moisture.
Ants are everywhere in the rainforest, and like hundreds of different species of ants. Ants that'll hurt you, ants that'll kill you, ants that'll eat you. Okay.
Ants don't kill people. Yes, they do. Yes, they do, bro. Depends on the ants.
Okay. But listen, okay, that's irrelevant. Sorry, I shouldn't have went there. Okay, but there's lots of ants in the rainforest, right? Okay, and it is estimated that, by the way, if you didn't get the date, there's the date. Okay, I'm gonna erase it now. Okay, it is estimated that there in 1 acre of the Amazon rainforest. Okay, there are 3.5 times 10 to the 6th power. That's how many ants are on 1 acre. Okay, now 1 acre, how big is 1 acre? Okay, what's that? 10 to the 6th, yeah. Okay, 1 acre is, okay, I think probably the whole school property here is probably 2 acres, maybe more. Okay, so it's probably about half. So in the ground, in an area about half the size of the school, there's going to be this many ants. Okay, so if you were to figure that up, write that into standard form, what would that be? How would I do that? Anybody remember?
You write the 3.1.
Write my number, and then how many places am I moving my decimal? 1, 2, 3, 4, 5, 6. Fill in these with zeros. What is that? That's 3,500,000. Okay, so in an acre, there are 3,500,000 ants. Okay, now let's say that there are, in the entire rainforest, there's 1.2 billion acres. Do you think we could figure out how many ants are in the rainforest? Do you think we could make an estimate of how many?
Yeah.
Okay, so we're going to have to multiply here some really large numbers, right? Yes, Mr. Kersey. So we don't want to do that, okay? I would rather put these numbers into scientific notation. So we already have this one in scientific notation, right? Okay, that's how many is in 1. I want to turn 1.2 billion into scientific notation. What does 1.2 billion mean? 1,200,000, okay? So that's like this, 1 billion, 200 million. That's how many acres there are in the rainforest, right? So can somebody help me turn that into scientific notation? Okay, Jewel, what would I do here?
You would have to find the first thing that's not a 0.
Which is a 1, right?
And then point 2
Uh-huh.
times 10, and then count how many zeros there are.
Can we just count the zeros?
No.
No. We have to count from where we put what?
The
decimal.
Yeah.
Decimal, which was right here, right?
It's 9.
9. Okay. Good. So what we have here, we have this is the number for 1 acre. This is the number for 1.2 billion acres. And this is how many are on 1 acre. What do you think I'm going to do with these two numbers? I'm going to multiply them. Okay. So I'm gonna try to do this down here. I'm going to write this out. 3.5 times 10 to the 6th. And I'm going to put parentheses around this because this is one part that I'm going to multiply. Okay. And I'm going to, if I don't separate these with an operation symbol, but just another parenthesis, what does that imply? What operation? Multiplication. So over here, I'm going to write 1.2 times 10 to the 9th power. Okay. You with me so far? Okay, what I'm going to do is I'm going to express my answer in scientific notation. Now, remember when we were multiplying polynomials? Okay, what did we do if they had coefficients? What did we do with those coefficient numbers?
Keep them the same.
No. Anybody? You multiply them, right? Right? Yes. Okay. So these are kind of like coefficients because this is like, if we treat this like one big term, we're going to take 3.5 and we're going to multiply it times 1.2. Tell me what you get. Do 3.5 times 1.2.
4.2.
Yeah, we get 4.2. Okay. So this means 3.5 times times 1.2 equals 4.2. That's the first part of our answer, right? Now, I dealt with this and I dealt with this. What's left? I have 10 to the 6th times what? 10 to the 9th. Well, I don't want to write all these numbers out, right? What's an easy way to do this? Since they have the same base, their base is both what? 10. What do I do with those exponents? Add them. Okay? So that's 10 and 6 plus 9 would give me what? Okay, so this would be 10 to the 15th. So my final answer would be 4.2 times 10 to the 15th power. That's how many ants are in the rainforest. Okay? Of course, it's an estimate, but do you see how we were able to multiply those to find that? Yeah? Okay, questions, Zuri?
I thought you were supposed to do 3.5 times 1.2 and then do 3.5 times 10. Right?
No. If we were distributing, yes, but we're not. That's a great question. Yes?
So are we going to be like figuring them out? Or just
No, this is what I'm looking for right here. It's easy. Okay, but, now, of course there's a but. Does everybody understand what we did there? Okay. So what if I gave you something like this? 9.35 times 10 to the 4th, and I'm going to multiply that times 4.78 times 10 to the 6th, okay? What's the first thing I'm going to do here?
Separate the 9.35 from the 4.
So I'm going to multiply these two, right? Okay. So 9.35 times 4.78. And somebody who did that, tell me what you got.
44.693.
Okay, so 44.693. Now I'm going to take my powers of 10. So this is 10 to the 4th times 10 to the 6th. What do I do with those? What do I do with these 4 and 6? You add them. So what's that going to be? 10 to the 10th. Now, remember, your answers have to be expressed in scientific notation. So, if this is my answer, what is wrong with that answer? Why is it not in scientific notation? Audrey? This number has got to be between 1 and 10, doesn't it? So let's go back to our rules that we talked about yesterday. Remember, exponent up means decimal where? I'm sorry, I did that backwards. Decimal this way means exponent what? Exponent up. Decimal this way means exponent what? Okay. Well, I need this to not be 44.693. I need it to be what? 4.693. So where does this decimal have to go?
To the left.
How many spots? 1. So I'm going to rewrite this 4.4693. If I went over 1, I went this way 1, my exponent has to do what? Go up 1. So this is going to be times 10 to the what? 11th power. Okay? Pretty simple, right? Audrey, what's your question?
So if that moved over 2 spaces, it would be times 12?
It would. It would go up 2. Okay? Are you with me so far? Okay? Can I do another one?
No.
Okay, I'll wait till you're ready. Yes, Jewel.
What if it's a number that's like, it starts with 1? Can it be a 10, since it's 1 through 10? And
Mhm.
it doesn't be a 10?
Nope. Has to be between 1 and 10. Good question.
So it can only be 9 or below?
Mm-hmm.
Oh.
Yo,
Why?
that's just the rules of scientific notation.
And
Yeah.
it's pretty much the same. Wait, back up. Is it the same thing with, like, if it would be below 1
Yeah.
and you would just move it together?
Mm-hmm. Okay, let me show you a couple more real quick, guys. Okay. All right. So, hey, thanks, Dan. You want a sucker?
I'm good, thank you.
Okay. All right. Okay, so let's take a look at another one and tell me what is different about this one. Okay, I have 8.91 times 10 to the 4th, and I'm going to multiply that times 2.73 times 10 to the negative 7th. Okay, what's different? Obviously, what's different?
A negative exponent?
There's a negative exponent. Do you think that changes anything about how we do this?
No.
We're still going to multiply our first two numbers. Okay, so 8.91 times 2.73. And then we're going to do 10 to the 4th times 10 to the negative 7. Okay, what's 8.91 times 2.73?
24.3243.
24 point what?
3243.
Okay, and when I get to this, okay, 10 to the 4th times 10 to the 7th, it's still going to be a power of 10. But do you think it changes? Do I still combine these two?
Yes.
Yeah, if I add 4 plus negative 7, that's the same as saying I have $4, but I owe 7. Are you still going to owe money?
Yes.
And if you owe money, it's what?
Negative.
Negative. So this is going to be 10 to the negative third. Okay, so let's write this. 24.3243 times 10 to the negative third. Okay, now, what's the problem still that I have to deal with? Okay, Natalie, what's the problem?
It's not between 1 and 10.
Yeah, I got to move it, don't I? How many spaces do I have to move it? So if I move this 1, it's now 2.43243, okay, times 10. Now here's where it's a little bit different. I'm going to add 1. I'm going to go up 1, okay? Think of it like a number line, okay? Like a vertical number line. If I go up from 0, they're all going to be positive. If I go down from 0, they're all going to be what? Negative. If I'm at negative 3 and I'm going up 1, it's not going to go to negative 4. What's it going to go to? Negative 2. Okay. Are you with me so far? Okay, one more example, and then I'm going to let you get started. Okay. Sometimes your starting numbers, and you're going to see this, sometimes your starting numbers are almost in scientific notation, but not quite. What do you think that means? Let's say I've got this. Let's say I got 340 times 10 to the negative third, and I'm going to multiply that times 0.00015 times 10 to the negative fifth. Okay? Are either of these numbers in scientific notation?
No.
They are not. Now, you don't have to put them into scientific notation before you multiply them, unless you want to. What I would do here, as long as my answer is in scientific notation, I'm okay. So should I go ahead and still multiply these? Okay, so multiply 340 times 0.00015. Tell me what you get.
0.051.
0.051.
Yeah.
Wait,
No.
0.051. Like that?
I probably did wrong.
Well, I got that.
Is there a 0 in front?
Yeah.
Okay, that doesn't matter, but that's fine. So 0.051, is that what you got, peeps? Okay, now let's take our exponents. Okay, I have 10 to the negative third times 10 to the negative fifth. What does that give me?
Negative
10 to the negative 8. Okay, that's not, it's a 0. That's a 0, Bowman.
8. Oh.
Okay, so let's write this out. I have 0.051 times 10 to the negative 8. Okay, what's wrong with my answer? It's not what? It's not scientific notation, right? So Chloe, how far do I have to move my decimal? 1?
I mean, 2.
3 times? What do I want 0.0051 to be? I want that to be what?
1 and 4.
Yeah, so 1 in 10. How do I do that? Which number? Look at it from left to right. Okay, if I move it here, what's it going to be? If I move this here, what's that going to be? 0.51. Is that no? If I move it another place up, is that now good?
Yeah.
Because now it's what? 5.1 times 10. Now, if you notice on this one, okay, did we go this way and up? We went this way, so our exponent is going to do what? It's going to go down. Okay, so we went this way how many places? 2. So this negative 8 goes down 2 more. What does that make? Negative 10. Very good. Okay. Easy, right?
Yeah.
Not that difficult. Okay, I'm going to let you get started.